Okay, here is the 2018 AP number 4. It's a non-calculator question, so when we work on the problem, we're not going to put full numeric answers down. Okay, so here we go. The height of a tree at time t is measured by the twice differentiable function. It just means it has a derivative, and this derivative has a derivative h, where h is measured in meters and t is measured in years. Remember, twice differentiable just means smooth. It means it's smooth, its derivative is smooth, and the one before is smooth as well. Several values of h of t are listed above. Use the data in the problem to estimate. I see estimate h prime. Prime means slope. And to estimate slope, we're going to use fib-faba. Fib-faba is our answer for this one right here. So h, this has to be written out, h prime of 6 is approximately h of 7 minus h of 5 over 7 minus 5 equals 11 minus 6 over 7 minus 5. If you want to leave it like that, you can. If you want to get it as a fraction, you can go like that. It also says use correct units. Interpret the meaning of the problem. Well, if h was measured in meters, then h prime, which is a rate, is measured in meters per year. And that is known as the rate of change of height. I-G-H-T. As soon as you take a derivative and you're going to put down what it's a rate of change of, you're going to write down a rate of change, you put down rate of change of the quantity there. Okay, explain why there must be at least one time t for between 2 and 10 such that h prime of t is equal to 2. Okay, so I'm going to flip to another page here for a second. Okay, we had a standalone lesson yesterday about the mean value theorem. Let's get close this page. There we go. Okay, let me erase this. The mean value theorem says if you have a function that's smooth and continuous, then somewhere in that interval there's a point where the average slope equals the instantaneous slope. It has to exist. And we use the mean value theorem to prove when there has to be at least these things here. So I have to find a region where the average slope is 2. So I'm looking at all my values here. I'm going to test them out. As a matter of fact, I believe if I went between 3 and 5, if the average slope from 3 to 5, let's see, would be 5 minus 3, 6 minus 2, 4 over 2 equals 2. Okay, so there is a region where the average slope equals 2. So to write this out as a definition, I would write down since h of t is differentiable and the average slope between 5 and 3, this should be enough, but I can write down between 5 and 3. Is 2, then by, we just write down MVT. We can use MVT. I showed you Wallace theorem yesterday. We really need MVT to prove things. Then by the MVT, there exists a point such that f prime of c equals 2. The big things to get the points on here are to write down the words mean value theorem. Okay, we're going to scroll down to our next section. It says use a trapezoidal sum with 4 subintervals indicated by the data in the table to approximate the average height of the tree over time interval 2 to negative 10. Now, we haven't talked yet about average value of a function. But I'm going to use the trapezoidal sum right now to find the subinterval. So I'm going to put a box on here so I can do work. Let's use trapezoids to find the area under the curve. Now, because this is a non-calculator, I'm not going to get it as an exact number. Oh, whoa, get back there, box. Oh. Hold on. There we go. Okay, let's get a red pen. Okay, so I did it again, didn't I? The area of the curve by trapezoids. There's going to be one trapezoid using those two, one trapezoid using those two, one trapezoid using those two, and one trapezoid using those two. So our area under the curve, and I'm intentionally writing this word, I'm going to use just letter A. So I don't have to write this out more than once. Area under the curve equals 1/2 the base times the sum of the heights. It's the first trapezoid. 1/2 base times the sum of the heights. Second trapezoid plus 1/2 base, sum of the heights. Three trapezoids plus 1/2 base times the sum of the heights. Three trapezoids. I've written them all out. Now that I've written them once, I can use the letter A. So this is the first time they asked us about average value. If you had to find the average of all the 5 tests you took, in general, you would add up. That means add up all your test scores. And if you had 4 tests, you divide by the number of tests you took. If we want the average value of a function, what we're going to do is we're going to add up all the values under the function, and we do that by integrating, because integrating means add, from A to B of that whole function. And over on this side, we divide by the number of tests we have. Well, we think of it this way, there's an infinite number of values under there, but what distance do they cover? They cover B minus A. It's just the length of the interval that you started out with. This interval is 8 units long. So for the average value, it's going to be A, the value we got before, area under the curve times 1/8. You can write that down. That's enough to do it. If you want to add a little more, some people will write this: 1/8 the integral from 2 to 10 of h of t dt. So the 8 on the bottom comes from this right here. It's like divide the length of your thing by the number of values you have by the length of the interval. Okay, so let's look at this last part of the problem. It's usually a very challenging part. If you can get through it, you're awesome. If not, don't worry. It's not mandatory for doing well on the test. They're probably going to try to throw a whole bunch of terms in there to confuse us. Let's see what happens. The height of the tree in meters can also be modeled by the function g equals g sub x, where x is the diameter, and that means g is the height of the tree. Hold on. G is the height of the tree. When the tree is 50 meters tall, so when g is equal to 50, the base of the tree, the diameter of the base of the tree is increasing at a rate of 0.3 meters per year. So I have a rate. This rate is of the rate of change of diameter, and diameter in our problem is x. So dx dt, when g is 50, equals 0.03. Is that number increasing? Yep, so I'll leave that as a positive number. According to this model, what is the rate of change of the height of the tree? Height is stored in g. At the time when the tree is 50 meters tall. So they want me to find dg dt when the height is g, equals 50. Okay, so I have a big equation to set up here. I need to find dg dt, which would be the derivative of this statement right here. So let's go ahead and derivate. I'm going to write down dg dt. Okay, so here we go. We're going to get dg dt. Change colors here for a minute. There we go. Didn't change colors, but there we go. dg dt equals the derivative of this one here based on times. So I've got a quotient rule. So it's going to be u prime, which is 100. Oh, too thick. Rule, u prime, 100. Why is it so thick? 100. And now, derivative of the top is 100 dx dt times 1 plus x minus u, which is 100x, times v prime, which is 1 dx dt, over v squared. So that's the information I need, and I'm going to find g dt when g is equal to 50. Well, there's nowhere to put in g. I need to know what x is when g is 50. So I'm going to come down to this equation right here. So 50 equals 100x over 1 plus x. And I can do the algebra on that, but I can already see that x is equal to 1. Because I put in 1 here, I get 100. 1 plus 1 is 2, so I'm going to fill in dg dt equals 100 dx dt, which is 0.03, times 1 plus 1, which is 2, minus 100, times 1, times 0.03, all that over 1 plus 1 squared, which is 4. I didn't have to fill those numbers in. I could have left it just by writing in the ones and things like that. If you feel the need to solve it out all the way, we can do that. dg dt equals, you don't have to go any farther than this. I factored out, by the way, a 100 and got this statement right here. So it's equal to 100 times 0.3 over 4. If you need to go any smaller from there, you can, but that's good enough. Hopefully the first two parts made sense, and you can follow along here. On to our next question.